We are moving on to 5.1, which deals with trigonometry. But first, we need to review the Pythagorean theorem. So if I had a right triangle and one side was 6 and one side was 8, we're going to use the formula a squared plus b squared equals c squared. Well, this is from a long time ago. What side are we missing? C. A and B can change, but C has to be the long side. So 6 squared plus 8 squared equals c squared. That is 36 plus 64, which is 100. No. So what do we do now? Nope, not in half. Square root it. So 10 equals c. Okay. Let's do another one. So that is if you're missing the hypotenuse. But what if I had 13 and 12 and I needed to find that side? What side are we missing? A or B? Oh, did you just get here? You didn't say your name when I called you. Oh, maybe I'm getting old. Sorry, I marked you absent. So, the missing side is either A or B. It doesn't matter. A and B are interchangeable. So we write a squared plus 12 squared equals 13 squared. A squared plus 144 is 169. Now what? Subtract 144 and we get a squared equals 25. Take the square root and we get 5. Okay, that will come into play in our assignment today. But first, we are going to learn about trig ratios. So in every right triangle, we have a hypotenuse and then 2 legs. And we realized a long time ago that if you take a right triangle and you stretch it, so, whoa, that won't work. I gotta fix it, do it a different way. Maybe. Okay, there we go. So if I take this triangle and I stretch it, what's happening to that top angle? This angle up here, is it getting bigger or smaller? It's getting smaller. So as the triangle stretches, the left side changes its length and the angle changes its size. And the same thing kind of happens if we stretch it this way. What's happening to that top angle? It's getting bigger. So when the bottom side gets longer, the top angle gets larger. And there are actually a lot of connections you can make between how big angles are and how big the sides are. Okay? So, we call that trigonometry. And when we use trigonometry, we have to be very specific on what sides we're talking about. So this side is called the hypotenuse. And like I said, the other 2 sides are legs, but there are 2 of them. And in the Pythagorean theorem, we call one A and one B, but we don't really care which is which. But you can see when I move that triangle, one side stayed the same length and the other one changed. So we can't call them legs. We have to give them other names. So what we do is we pick an angle. And that angle can have any name, but we usually call it theta. Theta is just a Greek letter. So the Greek alphabet, alpha, beta, gamma, delta, epsilon, zeta, eta, theta. So it's just a letter. In fact, I think that's... Huh? Yeah, theta, eta, zeta, zeta, eta, theta, something like that. Whoa. I didn't think you were here. For somebody who's not here, you're making a lot of noise. So the hypotenuse will always be called the hypotenuse, but the two legs need new names. And we actually describe them according to how they interact with theta, or the angle we're talking about. So this leg down here, it's next to theta. We call that leg the adjacent. Adjacent is the word that means next to. And then theta opens up and creates this side over here on the left. We call that side the opposite. And because we're lazy, we just say O and A. For Oakley Alton. So adjacent means next to, opposite means opposite. All right? Well, what if I put theta on the other side? Then the O and the A are going to switch places. So this comes over here, and this comes over here. Okay? And when we deal with trigonometry, we use an angle, and then we pick two of the sides. And the ratios we use have the names sine, cosine, and tangent. But mathematicians are really lazy, so we abbreviate, and we just have that. And if you say sin, cos, and tan, I'm going to make fun of you. So, here's what we do. The sine of theta is the opposite length divided by the hypotenuse, so O over H. The cosine of theta is A over H, and the tangent of theta is O over A. What does that mean? Well, let's get rid of these. Let's build a right triangle. Here's my right angle. Let's call this theta. What is the sine of theta? So using this angle here, 3 would be what length? This would be A, 4 would be O, and 5 would be H. Does everybody understand that? So sine is O divided by H. So in this case, it's 4/5. What about the cosine of theta? That would be A over H, which is 3/5. And the tangent of theta is O divided by A, which would be 4/3. Does everybody understand that? Deal. Okay. Well, how are you going to remember sine, cosine, and tangent? We use the mnemonic SOH CAH TOA. So sine is O over H, cosine is A over H, and tangent is O over A. And to remember that, we use the awesome phrase, some old hippie caught another hippie tripping on acid. Now, I said that in one of my earlier classes, and the kid's like, tripping on acid? And I said, it's okay. It's good you don't know what that means. But the journey you go on when you take acid is called a trip. And he's like, why would anybody drink acid? And they said, never mind. Just never mind. Don't worry about it. So apparently he'll never understand trig. Which I guess is a good thing. All right, so let's do 5, 12, and 13. Let's call this A, and let's call this B. What would the cosine of A equal? So cosine is A and H. If we look at angle A, the adjacent side would be 5, and the hypotenuse is 13. Okay, what about the tangent of B? So we look at angle B, and we need to do the O side divided by the A side. The O side would be 5, and the A side would be 12. What about the A side touches the angle, the O side does not. So the sine of B, if we look at B, sine is O divided by H. So the side that does not touch B would be 5, and H would be 13. What about the tangent of A? So if we look at angle A, we would do the 12, which is opposite, and the 5, which is adjacent, so 12 over 5. Okay, do you need to see another one? One more? So, let's see, C and D, 6, 8, and 10. So the sine of C. So we're looking at angle C. This will always be H. 6 is going to be which side? 6 is A, and 8 is O. Do you understand that, Oakley? So you pick your angle. H never changes, but the side that touches your angle is called A. Right, the problem will tell you. The problem will tell you which angle to use. Okay? And the angle you use will either be this one or this one. Why will the angle never be the right angle? Well, think about that. If I called this E, what is opposite E? The H. What is adjacent to E? The 6 and the 8. So you can't pick this one because it ruins our whole pattern system. So it'll tell you which problem to use, or which angle to use. So we pick C, we label the triangle, and then we look at sine. Sine is O over H, so that would be 8 over 10, which simplifies to be 4/5. Okay, what about the tangent of C? So the tangent of C has to be the O side divided by the A side, which would be 8 over 6, which is 4/3. So the A touches the angle, the O does not. The word adjacent means next to. Yeah. Opposite will always be the one farthest away. Yes? Well, so these problems tell you use angle C. But what if I asked you to find the sine of D? Now we have to switch this up. The H doesn't change, but this becomes O and this becomes A. So yes. Adjacent means next to, and then the other is just opposite. So the sine of D is going to be 6 over 10, which is 3/5. Okay? All right. The second set of problems just deals with your calculator. So it'll say, what is the sine of 20 degrees? And that's really hard to do. You just type in sine of 20. However, there are two ways to measure angles, and most calculators default on radians. So in this calculator, if I push mode, you see radians and degrees. So I need to go over and switch it to degrees, and that will give me a different answer. If you're using one of my calculators on the wall, you'll see a little rad or deg on your screen. We don't want this one. You have to use degrees. Your phone calculator will have some way to switch between radians and degrees. You have to make sure that your calculator's in degrees or you'll get the wrong answers. It's on Alex. Okay, the last problem will do this. It will say 10, 25, and theta, and it will say, what is the sine of theta? Well, that's going to be opposite over hypotenuse, but I don't know what this side is. Now you have to do, oh wait, that's not, 25 won't work. It's got to be 26. Sorry. So now we do the Pythagorean theorem. 10 squared plus b squared equals 26 squared. So we get 100 plus b squared. What is that? 320. I don't know. What is it? 676. So we subtract 100. We get b squared equals 576. Square root that, and I get 24. So what is the sine of theta? 24 over 26. I can take a 2 out of that, which is 12/13. That's it. It is. There are only 3 types of problems on your assignment, though. So, maybe I didn't do it. We'll see.